Welcome to the Crazy Hat Chemist, a whole new unit here on solutions and their behaviors. So let's get moving with the first one. Here we go. We got to get a definition of a solution. So, bam! So today we're talking about definitions of solutions. So a solution is a homogeneous mixture of two or more substances in a single phase. Okay? One constituent is usually regarded as the solvent, always in the greater quantity, and the others is the solute or the solutes, though the solute is always in the lesser amount. So here's what you need to know. It's a very simple mathematical problem. That is, the solution is equal to the solvent plus the solute. So here in chemistry we have the solution to all your problems. It's the solvent plus the solute. That's equal to your solution. So here's a really simple way to remember this equation and not mix it up. So the first one, the solvent, is a number 7. So how many letters in the word solvent? 7 letters. How many letters in the word solute? 6. Notice that solute has fewer letters than solvent. Therefore, the solute is in the lesser quantity. And the solvent has more letters, so therefore it's in the greater quantity. So we're going to add these two numbers up, and what number do you think you're going to get? Of course, we're going to sum these up, and we're going to get, 8. That's right. So you can tell your math teacher this is the first time when 7 plus 6 does not equal 13, but it equals 8. Okay, because there are 8 letters in the solution to all your problems. Okay, so remember, the solution is the sum of the solute plus the solvent. That's why it has the most number of letters in it. The solute has the fewest number of letters, and it's in the least amount. And the solvent is what you put the solute into to make the solution. That is the sum of the two. So hopefully you can remember that little mathematical problem there, and that will solve all your problems and be the solution to all your problems, of course. Okay, so there are 3 classifications of solutions, of which each one of these is temperature dependent. Okay, first, you have an unsaturated solution, and that has the ability to contain more solute than is dissolved into it at that moment in time. So this is an example of a bunch of different solutions that are unsaturated. Notice that there is no solid on the bottom of any one of these. That first one is potassium chromate. Then we have lead 2 or plumbous nitrate. We have calcium nitrate. We have Nicholas chloride. And we have ferric nitrate right there. All of these are unsaturated solutions. That means that there is more solute that can go into the solvent. The solvent is water in this case, and water is called the universal solvent because the vast majority of things can go into it, and that's what we use for chemistry. Okay, notice in this picture here that there are some solutions that are colorless. For example, the lead nitrate. The vast majority of solutions are colorless. But there are also solutions that have a color to them besides just food coloring, right? So that potassium chromate, which is yellow in color, the cupric nitrate, okay, has a blue color in it. So, and then the Nicholas chloride has a green color, and the ferric nitrate has the red color. And it is actually the cation that actually is most of the time related to the color, but not always. Okay, the copper 2+ ion is blue in solution, the nickel 2+ ion is green in solution, and the iron 3+ is yellow orangey in solution. It's actually the anion, which is the in the potassium chromate. It's the chromate that has the yellow color. Okay, and neither the nitrate nor the lead have a color to them. That's why the lead nitrate is colorless. All right, so let's go on to the next one. The next one is a saturated solution. A saturated solution contains the maximum quantity of solute particles dissolved in the solvent. Okay, and so here's an example of a saturated solution. It's saturated sodium chloride. Okay, I have solid sodium chloride on the bottom here of this, and then it's saturated sodium chloride solution above it. So a saturated solution is the easiest to make. You dump in a bunch of solid, you dump in the water, you mix it up until you still have solid remaining at that temperature. Remember, all these are temperature dependent. So then what you can do is you can carefully decant, that is, pour off the liquid layer that's on the top of this saturated solution of sodium chloride, and then you have no solid in there. But in order to maintain having a saturated solution, you need to have some of that solid in there at that temperature, just in case the temperature increases and more solute goes into solution. Okay? All right, now let's go on to the next one here. The next one is a supersaturated solution, and a supersaturated solution is kind of counterintuitive, but it has more solute particles than is possible that can go in it. Okay, and that seems rather strange, and these are very typically unstable. Okay, once you get a saturated solution, then you really can't get a supersaturated solution except under certain circumstances. And this here is a supersaturated solution of sodium acetate. It's actually in the process of going to a supersaturated solution. It's not quite in a supersaturated solution at this moment in time because there is some solid there, and this is how you make it. So how you make a supersaturated solution is right here as follows here. You're going to take, in this example, sodium acetate, okay, and you're going to add a little bit of water to it. Then you're going to heat it up with a Bunsen burner, and you're going to make all that go into solution. Okay, so now you have a solution. That right there still has solid, so it's right in the progress of going towards a supersaturated solution. Once you have it all into solution, then you're going to let it sit there. Now, you're going to let it sit there until the temperature decreases of that saturated solution. Once the temperature decreases and you are not having any solid fall out of solution, then you have a supersaturated solution. So I will show you another video of where you have a supersaturated solution. But until then, okay, I am the Crazy Hat Chemist, and of course we've got a crazy hat going on over here. And it is time to go relax, chillax, and go fishing. If you like that video, give me a thumbs up, subscribe to my YouTube channel, and I'm going to see you next time for more properties of solutions, and answers to all your solutions are right here with Mr. Montbrion's The Crazy Hat Chemist. Bye now.